So I'll be sharing my screen to get started with the AMC-8 2018 problems and solutions today. So the agenda for today is that we'll be doing the AMC-8 2018 problems and we'll be discussing strategies and tips. There'll also be a question and answering session where you can ask some questions and I'll be able to answer them. Problem number one. An amusement park has a collection of scale models with ratio 1 to 2 of buildings and other sites from around the country. The height of the United States Capitol is 289 feet. What is the height of in feet of its replica in the park rounded to the nearest whole number? So they told us that the ratio is 1 to 20, and they also told us in real life the United States Capitol is 289 feet. And when it's 289 feet, since we need to find its replica, which is 1 to 20, then we would have to do 289 feet by 20, 289 divided by 20. And once we solve this, then we're gonna get 14.45 over 1, which is the same thing as 14.45. And they're asking us, what is it rounded to the nearest whole number? So whole numbers are basically like the counting numbers, so like 1, 2, 3, 4, 5, and so on. It's like the nearest integer. And when we round it to the nearest whole number, then we're gonna get 14. And so our final answer would be A, 14. Problem number 2. What is the value of this product? So they gave us a list of all the things that we have to multiply. So instead of writing this as like this, instead of like 1 plus 1 over 1, instead of like that, we can make it an improper fraction. And to make it an improper fraction, then we would have to do 1, so 1 plus 1 plus 1 over 1 would be equal to 2 over 1, which is the same thing as 2. So 2 over 1 times, and plus this dot over here, it represents multiplication. So 2 over 1 times 3 over 2. And we got 3 over 2 because it's 1 over 2 plus 1. 1 whole is equal to 2 over 2 or like 3 over 3 or 4 over 4 and something like that. So 2 over 1 times 3 over 2 times 4 over 3 times 5 over 4 times 6 over 5 times 7 over 6. And we stop here because it doesn't say that. It doesn't say dot, 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 which means keep going on. It just stops at 1 plus 1 over 6, which is equal to 6 over 6, plus 1 over 6, which is equal to 7 over 6. And now, instead of multiplying all of these, instead of multiplying the top number times the bottom number, we could just cancel out. Remember how multiplication and division both cancel out with each other? Then we can do 2, we can cancel out the 2's, we can cancel out the 3's, cancel out the 4's, cancel out the 5's, cancel out the 6. And we cannot cancel out the 1 and 7 because there's nothing that can be canceled out with them. And so we're gonna get 7 over 1. Just write the top number over the bottom number. And when we get 7 over 1, the answer is just gonna be equal to 7. And that's how we got our answer choice D, 7. Problem number 3. Students Arn, Bob, Sai, Dan, Eve, and Fawn are arranged in order in a circle. They start counting. Arn first, then Bob, and so forth. When the number contains as a 7 as a digit, such as 47 or a multiple of 7, that person leaves the circle and the counting continues. Who is the last one present in the circle? So I'm going to start by listing out the people in the circle. So A for Arn, B for Bob, C, D, E, and F. So that means that there's going to be 6 people in the circle, and usually they're going to be in a circle, but since that we cannot physically draw a circle on this, well, we can draw a circle like this, but I just drew it as a straight line so that it could be easier for us. so that there's 6 people in a circle. Then, so we start by counting with R. So R is going to be 1, B is going to be 2, C is going to be 3, D is going to be 4, E is going to be 5, and F is going to be 6. And then we continue with the circle because it's a circle and so it keeps going on. So F is going to be 6 and A is going to be 7. When A is equal to 7, well, we're going to cancel A because if it contains a digit such as 7 or a multiple of 7, then that person leaves the circle. That person is excluded from the circle, but the counting still continues. So after A is being canceled out, then we can do 8 is B, 9 is C, 10 is D, and then it's going to be 11 equals E, 12 equals F. And remember how A is canceled out, so we don't count A in this case. So we're going to skip A, we're going to go directly to B. So B is going to be 13 and C is going to be 14. So when C is going to be 14, we're going to cancel this out as well. Because if it is a multiple of 7, then that person also gets excluded. So if C equals 14, then that means that D has to be equal to 15, E has to be equal to 16, F has to be equal to 17. Once again, if that number contains 7, then that person is also excluded. It says that right here. So then so we have 3 people excluded, and that means that there's only 3 people included in the circle. So we're gonna continue counting. We're gonna get 18 is B, 19 is D, remember we skipped C, 20 is E, and 21 is B. If it's a multiple of 7, then that person will also get excluded, so B is excluded. And then D is going to be 22, 23 is going to be E, 24, 25, 26, and 27. So that means that E is also going to be excluded out of the circle. So the last one remaining is going to be D. So the last one remaining is going to be Dan. And that's how we got our answer choice D. Problem number 4. The 12-sided figure has been drawn on a 1 centimeter by 1 centimeter graph paper. What is the area of the figure in centimeter square? So to find the area of this shape in this figure, then we will have to we can try to find the area of this inner part here. So I'll be trying to draw a square here, so that we can like measure this part. So this can be a square here. And so this square, as we know, this square is gonna be a 3 by 3 since this is 3 and this is 3. This is gonna be 3 times 3. So 3 times 3, if we multiply it, then we're gonna get 3 times 3 is equal to 9. So the middle part of the shape is gonna be 3 times 3, which is 9. Now we need to find what is the area of this triangle here. So what is the area of that part, that part, that part, and that part? So since there's 4 triangles, 1, 2, 3, and 4, we need to find the area of one of them, and then we can multiply that by 4. So we need to find the area of one of this. If we put this triangle, so split this triangle in exactly half. And then if we put this triangle, so once we split that triangle in half, if we put this half of the triangle over here, it's going to become a 1 by 1 square. And so the area of one of these triangles is going to be equal to 1. Another way you can solve this is that there's going to be 1 over here. So this part is going to be 1 because they told us that it's a 1 centimeter and 1 centimeter. So this part is going to be equal to 1. And then that means that the height is also going to be equal to 1. Since it's a 1 centimeter by 1 centimeter, it's going to be a square. So this side is also equal to 1. And then we can do base times height, 1 half times base times height. So it's going to be 1 half times base times height, which is 1 half times 1. Because 1 times 1 is equal to 1. 1 half times 1 is just equal to 1 half. And then we need to do 1 half times 2 because since there's 2 triangles, not 1. So if we do 1 half times 2, then we're going to be getting, cancel out the division and cancel out the multiplication, then we'll be getting 1. So once again, we just proved why one of the triangles will be equal to 1. So since there's four triangles, we'll have to do 1 times 4, so 1 times 4, which will be equal to 4. And 4 is not an answer yet because we'll have to add the area inside the squares, and then we'll be getting 4 plus 9, which will be equal to 13. And so the total area of the shape is going to be 13 square centimeters. So that's how we got to answer choice C. Problem number 5. What is the value of 1 plus 3 plus 5 and so on till 2017 plus 2019 minus 2 minus 4 minus 6 all the way until negative 2016 minus 2018? So we can start off by solving this problem by doing well, we can start off by doing 1 minus 2, 3 minus 4, 5 minus 6, and so on like that. So I'll be writing this right here. So in parentheses, I'll be doing 1 minus 2 plus 3 minus 4. And this is just a simpler way to cancel out the numbers. So 1 minus 2 plus 3 minus 4 all the way until 2017 minus 2018. And we just do, when we don't do 2019 minus 2020 because there's no 2020. It just stops at 2018. So once we solve this, then we're going to get 2018. So 2018 negative 2018 divided by 2, since there's two pairs of numbers. So 2008 negative 2018, since negative 2018 is a negative number, so negative 2018 divided by 2, which is gonna be giving us negative 1009. So we got negative 1009 here. So negative 1009 plus 2019. So I'll be writing this here because we don't subtract 2019 from anything. So we have to do negative 1009 plus 2019. And if we were to solve this, then we would be getting 1010. Since negative 1009 plus 2019 is going to be giving us 1010. And that's how we got our answer choice E. Problem number 6. On a trip to the beach, Anne traveled 50 miles on the highway and 10 miles on the coastal road axis. He drove 10 times as fast on the highway as on the coastal road. If Anne spent 30 minutes driving on the coastal road, how many minutes did his whole entire trip take? So, if Anne traveled 50 miles on the highway, 10 miles on the road, and he drove 3 times as fast as a highway than on the coastal road. Anne spent 30 minutes driving on the coastal road. So that would be 1/2, since there's 60 minutes in an hour. It'll be 1/2, so half of 60. So half of the 1 hour. So that will be giving us 30 minutes. So 30 minutes. I'll just write 30 per minute. So then to find out the speed, well, speed is gonna be distance over time. So the distance, so then to find out the total, so to find out how many miles he drove, so he drove 10 miles in 30 minutes, then how many miles can he drive in 60 minutes? It's gonna be simply, so we can do X or question mark, or we can do it to 60. So we can be doing X to 60. Well, what times what gives us 60? So 30 times what gives us 60? Well, 30 times 2 gives us 60. And 10 times 2 will be giving us 20. So that means that X is going to be equal to 20. So that means that he drove 20 miles per hour. So 20 miles per hour. So 20 mph. And then he says that he drove 3 times as fast on the highway as on the coastal road. If he drove 20 miles on the 20 miles per hour on the coastal road, then how many miles per hour did he drive on the highway? That's simply going to be 20 times 3 miles per hour, which will be giving us 60 mph. So if he drove 60 miles per hour on the highway and he had to drive 50 miles in total, then that means that he can drive 1 mile per hour. Since there's 60 minutes and he drove 60 miles per hour, he can drive 1 mile in 1 minute. So that means that in total on the highway, he took 50 minutes to drive because he can drive 1 mile in 1 minute. If he drove 50 miles, then how many minutes would it take? Well, 1 times 50, which will be giving us 50. So he took 50 minutes plus, he took 50 minutes plus the 30 minutes here. So 15 minutes plus the 30 minutes they gave us in the problem. Well, 50 plus 30 will be giving us 80, and that's how we got our answer choice C. Problem number 7. The 5-digit number 2018U is divisible by 9. What is the remainder when this number is divided by 8? So they're asking us that they gave us one statement. 2000 and 20,018. So this U is also a digit, so it's gonna be shifted one place. So it's gonna be 2018 blank is divisible by 9. That's one statement. We have to fulfill that statement, and then we have to divide that number by 8. And then that just asks for the remainder. So 2018 blank. I'll just leave that because we're gonna be filling that spot later. So 2018 blank divided by 9 is going to be giving us some number. So we can start off by doing 20 divided by 9. And 20 divided by 9 is going to be equal to 2. And then carry the 2 here. 21 divided by 9 is going to be also 2, remainder 3. 38 divided by 9 is going to be equal to 4. Then carry the 2 there, and it's going to be 2 times something. Well, the multiples of 9 are 2 times are 9, 18, 27, 36, and so on and so forth. So then 27 is the only digit is a 2-digit number, and that is a multiple of 9 is going to be 27. So that means that this number has to be equal to 27. So I'll be changing the color just for this digit, so it's going to be equal to 7. So we know that U can be equal to 7, and then our final answer will be equal to 2243. 27 divided by 9 is equal to 3. And so we have our number 20187 divided by 8 is equal to, well, we need to solve that. So 20187 divided by 8 is going to be giving us 20 divided by 8 is going to be equal to 2, and then there's a remainder of 4. So 41 divided by 8 is going to be giving us 5, and then 8, and the remainder 1. So 18 divided by 8 is going to be giving us 2, remainder 2. So then 27 divided by 8 will be giving us 3 remainder. So to find out the remainder, we're going to be doing 27 minus 8 times 3. So 27 minus 8 minus 24 is going to be giving us remainder 3. So then our answer would be 2523 remainder 3. And so our final answer would be remainder 3. And that's how we got our answer choice B. Since they're only asking us what is the remainder. Problem number 8. Miss Garcia asked the members of his health class how many days last week they exercised for at least 30 minutes. The results were summarized in the following bar graph, where the heights of the bars represent the number of students. So they're asking us that they exercise at least 30 minutes. Well, that number we don't really need because it doesn't really matter, but we'll just leave that there. So they're asking us how many students exercised here, and they're asking us that what is like they're asking us what is the average. Mean means average. So they're asking what is the average number of days last week, rounded to the nearest hundredth, reported by the students in Miss Garcia's class. So there's gonna be so to solve this problem, we're gonna be doing so there's gonna be to know so we can count the number of students that participated. So 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that means that there's 25 students who participated in this challenge of his health class. So then we would have to do, so we can do 1. So 1 times 1, it's going to be 1 plus plus 2 times 3 is going to be 6, plus 3 times 2, which is going to be also 6, plus this is going to be 6 times 4, which is going to be equal to 24, plus this is going to be 5 times 8, which is actually going to be equal to 40, plus 6 times 3, which is going to be equal to 18, plus 7 times 2, which is going to be equal to 14. So then we would have to add all of these numbers up. And if we add all of these numbers up, then we'll be getting, well, I'll be writing this right here, then we will be getting 109 over 25. And then if we would solve 109 over 25, then we would be getting 4.36. So since we got this number and it's rounded to the nearest hundredth, it's rounded to the nearest hundredth, and then that would be our answer choice C. 4.36. Problem number 9. Tyler is tiling the floor of his 12-foot by 16-foot living room. He plans to place 1-foot by 1-foot square tiles from a border along the edges of the room, and to fill the rest of the floor with 2-foot by 2-foot square tiles. How many tiles will he use? So Tyler has a rectangular living room with a 12-foot by 16-foot. So this is going to be how the rectangle of his living room will be looking like, or it'll be looking something like this. So now, he told us that there's going to be, well, he wants to do the border. So he wants the border to be a 1 by 1. So the border will be, I'll be changing the color. So the border will be looking something like, so the border will be looking something like this part. So this part inside, it will be the inner part, and the border will be the outer part here. And so to find the area of the outer part of the border, we will be doing, since we know that this is going to be 12 and this is going to be equal to 16, then we will be doing 16. Well, we can split it like this so that we don't cut the corners twice. We can be splitting it like this. And we can do a 12 times 2, since it's going to be the same on this side, and it's going to be the same on this side, we can do 12 times 2, which is going to be equal to 24. And then we can also do 16 minus 2, which is going to be equal to 14 here. Since we already counted this corner and this corner, and since we know that each one is 1 by 1 foot, we can do 16 minus 2, which is going to be equal to 14. And so we can do 14 times 2, since it's going to be the same on the top and bottom. We're going to get 14 times 2 is going to be equal to 28. And we can add 24 plus 28 to be giving us 52. And so now we know the border of the outer part of the rectangle, but then we're going to have to know the border of the inner part of the rectangle. By inner part, I mean the shaded part over here once again. So to find the area of this inner part, we know that this part is going to be equal to 10 here, since this is going to be 2, 2, and this part is, we already know this part is going to be equal to 14. And we got 10 because of 12 minus 2. And so to find the area of this part, we're going to be doing 10 times 14, so 14 times 10, which will be giving us 140. But remember how they said that the inner part will be a 2 by 2 square tiles? So we're going to have to do, 2 by 2. So we're going to have to do 140. So 140 divided by 2 by 2. So 2 squared is going to be equal to 4. So 140 divided by 4 will be giving us 35. So now we know the border of the whole entire rectangle, and we know the inner part of the whole entire rectangle as well. So then we can just simply add both of them together. So if we do 35 plus 52, then we can be getting 87. And that's how we got our answer choice B.
Can you turn off the video except Manya remaining one? Turn off your videos.
Problem number 10. The harmonic mean of a set of non-zero numbers is the reciprocal of the average of the reciprocal of the numbers. What is the harmonic mean of 1, 2, and 4? So first of all, there's many terms in this problem that we may not know the meaning of. So the harmonic mean. So the mean means average, so I'll be writing average here. Average here. And non-zero here. I'll be telling the meaning of harmonic later, and they'll be telling us the meaning of harmonic in this problem as well. So non-zero means not equal to 0. So I'll be doing a not equal sign here, and not equal to 0. Is it reciprocal? Reciprocal means that if the number, suppose that the number is equal to x, then the reciprocal would be equal to 1 over x. So the reciprocal is just the opposite, or it's going to be 1 over that number. And the average is going to be the mean again. So the harmonic mean of a set of non-zero numbers is the reciprocal of the average of the reciprocal. Reciprocal, once again, it's the same meaning here, of the numbers. Where it is a harmonic mean of 1, 2, and 4. So basically the harmonic mean, suppose that the numbers are x, comma y, comma z. So the numbers are x, y, z. Then the reciprocal would be 1 over x, 1 over y, and 1 over z. This is just a reciprocal. So what is the harmonic mean of the numbers? So we need to first, they gave us the numbers right here. X, Y, and Z is just an example. So they gave us the numbers right here. So first we need to find the reciprocals of the numbers. So the reciprocals of the numbers would be 1 over 1 plus 2, 1 over 2 plus 1 over 4. This is the reciprocal of these numbers. And to find the average of these numbers, we're going to first add them and then divide them by 3. So if we add these all together, then we would have to have a common denominator. And to have a common denominator, then we would have to find the least common multiple of 1, 2, and 4. And the least common multiple would be 4, since 4 is a multiple and factor of 4. So the least common multiple would be equal to 4. So 1 over 1 is going to be equal to 4 over 4. 4 over 4 plus 2 over 4. 1 over 2 is equal to 2 over 4 plus 1 over 4 is equal to 1 over 4. So 4 over 4 plus 2 over 4 plus 1 over 4. Well, we can just add the top number, the numerator, since all the denominator is the same. So 4 plus 2 plus 1 is going to be equal to 7 over 4. So this is just the total of them, but we would have to do 7 over 4, so I'll be writing 7 over 4 here. 7 over 4 divided by 3, which is the same thing as 7 over 4 times 1 over 3. And so 7 over 4 times 1 over 3 would be equal to 7 over 12. And that's our final answer because they're asking what is the reciprocal of the average of the reciprocals of the number. The reciprocals are 1 over 1, 1 over 2, and 1 over 4. The average would be equal to 7 over 12. And we need to find the reciprocal of that. So then we would have to switch the top number and the bottom number. And then if we switch both of them around, then we'll be getting 12 over 7. And that's going to be our final answer, choice C. 12 over 7. Does anyone have any questions on this problem? Okay, if no one has any questions, then we'll continue on to question number 11. Problem number 11. Abby, Bridget, and 4 of their classmates will be seated in 2 rows of 3 for the group picture as shown. If the seating positions are assigned randomly, what is the probability that Abby and Bridget are adjacent to each other in the same row or in the same column? So adjacent means next to each other. So Abby and Bridget can be over here. They can be over here since they can be in the same row or the same column. And they can be over here. They can be like that. They can be like that. They can be like that. And they can be like that. So they have many different possibilities. So they have 7 possibilities like that. 4 of the so 1, 2, 3, 4. Then it's gonna be 5, 6, 7. So there's gonna be 7 possibilities like that. And so now since there's 6 places and we're gonna have to choose 2 of them, then we can do 6C2, which is the same thing as 6 choose 2, and that will be giving us 6 factorial over 2 factorial times 6 minus 2 factorial. So that's going to be equal to 4 factorial. So we can be doing 6 times 5, 6 times 5 times 4 factorial. We can represent 6 factorial as 6 times 5 times 4 factorial over 2 times 1 factorial, which is the same thing as 2 times 1, times 4 factorial. And so the top number and the bottom number, 4 factorial will be canceled out with each other. And then the 2 and the 6 will be canceled out to 3. And so so 6 choose 2 will be equal to 15. And this is the total number of possibilities that they can be sitting like that. And this is the possibilities that they will be sitting next to each other. So the probability in total will be equal to 7 over 15. The probability formula is the success rate over the total possibilities. So the success rate is equal to 7 since they can be sitting in 7 different ways over 15. So the total is going to be equal to 15, and that's how we got our answer, 7 over 15C. Problem number 12. The clock in Sri's car, which is not accurate, gains time at a constant rate. One day, as he began shopping, he noticed that his car clock and his watch, which is accurate. So his car is not accurate, and his watch is accurate. They both say 12 o'clock. So both of them are accurate so far. When he is done shopping, his watch says 12:30 and his car says 12:35. Later that day, Sri loses his watch. He looks at his car clock and it says 7 o'clock. What is the actual time? So once again, we know that Sri's car is not accurate and his watch is accurate. But then he loses his watch. So then we're gonna have to find the actual time. So his car clock says 12:35 and his actual watch says 12:30. So then the rate would be 30 minutes to 35, which is gonna be, well, if we divide both sides by 7, it's gonna actually be equal to 6 to 7. So if it's 6 to 7, then his car clock at 7 o'clock says that it's 7. But since we know that the rate increases by 7, then it's gonna be so. Then we're gonna have to we're gonna have to find the actual time. So then, if it's equal to 6 to 7, then we're gonna have to find the actual time. So then, if it's so if it's 7 o'clock to what o'clock? Well, if it's 7 o'clock here, so 7 o'clock here, then what time would it be? Well, if the rate is still at 6 to 7, then then it would be equal to 6 o'clock. So 6 o'clock is gonna be the actual time here, and so 6 o'clock in this case for his car is gonna be equal to 7 o'clock. So then our answer would be D6. Problem number 13. Layla took 5 math tests, each worth a maximum of 100 points. Layla's score on each test was an integer between 0 and 100 inclusive. Layla received the same score on the first 4 tests, and she received a higher score on the last test. Her average score on the 5 tests was 82. How many possible values are there for Layla's score on the last test? So they told us that her score is out of 100, and it must be and it can be 0 and 100. Because I said inclusive, which means that it can be 0, 100. The one point that they told us is that the average on her 5 tests was 82. So if the average on her 5 tests was 82, that means that the first test must be less than 82, and the second or the last test must be greater than 82. So since Layla received the same score on the first 4 tests, suppose that so on the first 4 tests, and since the average is going to be equal to 82, we'll find the total. So the total would be equal to 82 times 5, which will be giving us 410. So since 410 is the total, then suppose that she got 81 on one of her tests. So if she got 81 on one of her tests, then we're going to have to do 81 times 4, which will be giving us 324. So then if she got 324, then we will have to be doing 410 minus 324. And if we do 410 minus 324, then we will be getting 86. So 86 is one of the possibilities. Then if we keep decreasing, so if she got 80 on one of her tests, then we would be getting 90 on her 5th test, and then we would be getting 94, and then 98, and then we cannot get 102, because if we do get 102, they already told us that there is a maximum of 100 points. So then that means that 80, so 86 is the lowest. If she got 82 in one of her tests, well, she can't get 83 because then the average would not be 82. It will not be an integer then, because they already told us the average would be 82. So then there's 4 total values of the possibilities. So 86, 90, 94, 96. And that's how we got our answer choice A. Problem number 14. Let n be the greatest 5-digit number whose digits have a product of 120. What is the sum of the digits of n? So n is the greatest 5-digit number whose digits have a product of 120. So I'm going to do five empty spaces for the 5 digits. So five empty spaces for the 5 digits. And so we're gonna list out all of the factors, all of the 1-digit factors of 120. And so I'll be doing remember 1-digit factors of 120 are 1, 2, 3, 4, 5, 6, 8. These are all of the 1-digit factors of 120. Well, what's the greatest number? The greatest number is 8. 8 times what will be giving us 120? 8 times 15 will be giving us 120. So then that means that 8 times, well, what is the prime factorization of 15? Or the factors of 15? Well, 8 times 3 times 5 will be giving us 120. And so we can write that here, but remember we're going to have to arrange this in greatest to least. So then that would be giving us 8 times 5 times 3 times blank times blank. Well, remember that 1 times any number is just going to be equal to that number. So 1 times x is just going to be equal to x. So then these two numbers can be equal to 1. Well, then why can't we place as many 1s as possible? Well, that's because this number is a 5-digit number. It's only 5 digits. So then that means that the 5-digit number is 85,311. Well, so we're gonna have to add all these up. So we're gonna, because they're asking for the sum. So then we're gonna be doing 8 plus 5 plus 3 plus 1 plus 1. And if we add all these up, then we'll be getting 8 plus 5, which is going to be equal to 13. 13 plus 3, 16. 16 plus 1, 17. And 17 plus 1 is going to be equal to 18. And that's how we got our answer choice D. Does anyone have any questions on this problem? Okay, problem number 15. In the diagram below, the diameter of each of the two smaller circles is the radius of the larger circle. If the two smaller circles have a combined area of one square unit, then what is the area of the shaded region in square units? So to find the area of the whole circle, I'm gonna write area. So the area would be equal to the whole circle. So I'm gonna write whole circle, or I'll just write writing whole minus the white area. So the whole circle minus the white circle. So, now we already know the area of the white circles is going to be equal to 1, but this is for both of them combined. So it's going to be equal to 1. But the problem with that is that we need to find the area of the whole circle. How do we find that? So the area of the circle in general would be equal to, the formula would be equal to pi radius squared. What's the radius? Well, we can find this out. So one of the circles will be equal to 1 over 1, 1 divided by 2, which is going to be equal to 0.5, which is the same thing as 1 by 2, 1/2. So that means that pi r squared, well, pi r squared would be, well, pi is approximately 3. So we can do 3 times, so we can do 3 times r squared. So r squared would be equal to, if we want to do r squared, then that would be equal to approximately 1 by 2. So 3 times 1 by 2. So 3 times 1 by 2, which will be giving us approximately, or wait, so that will be giving us a 3 by 2. So then that means that the radius of the total area of the circle, so then the radius would be equal to 3 by 2. And so remember that the formula of the circle, would be equal to pi r squared. We have that right there. And so the radius would be equal to, since the radius is equal to 1 by 2, well, we will have to do divide by 2. So since we got the radius is equal to 1 by, since the radius should be equal to 1 by 9, yeah, it should actually be equal to 1 by 9 since it's going to be equal to, the radius is not 3 by 2, it's actually 1 by 9. Because we're going to have to do the 3 times three 1 by 3 square to find the radius of this part. And so to find the radius, to find the area of the whole circle, we're gonna have to do pi times 1 by 9. Since the radius is equal to 1 by 3, we're gonna have to do the radius, so 1 by 3 square, which is going to be equal to 1 by 9. And if we do that, then we're going to be getting 3. So the pi is approximately equal to 3. Pi is like 3.14, but it's approximately equal to 3. So I'll just write pi as 3. So 3 times 1 by 9. And if we do that, then we're going to be getting, since 3 can go into 9 2 times, since it's a square, then we'll be getting the radius, the radius here, the radius will be equal to 1 by 2. And since there's two circles like this, well, we will be getting 2 by 9. So it's gonna be equal to 2 times 9. So 2 times 1 by 9, which will, yeah, someone has a question?
So, but like, wait, doesn't 3 go into 9 3 times, not 2 times?
Oh yeah,
Just one-
well, 3 goes into 9 2 times, but we're gonna have to do the square since it's a radius square.
Oh, okay.
Yeah, so it's gonna be equal to 2 by 9. Well, this part, it won't really matter for now. It won't really matter, okay? So since we got 2/9, so 2/9 times pi. So 2/9 times pi, and that will be giving us, that will be giving us, we'll have to do 2/9 square as well. So 2/9 square, that will be giving us just the top number square since it's just going to be the top number. So it's just going to be the radius. So we just need the top number since we already know that the bottom number is going to be this part. And so we just need the times 2 for the top number. And that will be giving us 4/9 times pi, times 3. Or 3, so and then that will, if we divide by 3, then we'll be getting, that will be equal to 2. So then the area of the whole circle will be equal to 2. And so since the area of the whole circle will be equal to 2, and they already gave us that the area of the if the area of the two smaller circles is equal to 1, they have a total area of 1, then we're gonna have to do 2 minus 1. And since 2 minus 1 is equal to 1, our final answer would be answer choice D, 1. Does anyone have any questions on this problem? Okay, so if no one has any questions, then we can have a 2-minute break since we finished problem number 15, and we'll restart and we'll be continuing in 2 minutes. So we'll be continuing at 10:52 PST. So our break is over and we can continue with the problem number 16. Problem number 16 says Professor Chang has 9 different language books lined up on a bookshelf. 2 Arabic, 2 German, and 4 Spanish. How many ways are there to arrange the 9 books on the shelf, keeping the Arabic books together and keeping the Spanish books together? So we know that Professor Chang has 9 different books. They're all lined up on a bookshelf. And he wants to keep the Arabic books together and the Spanish books together. There's 2 Arabic and 3 German and 4 Spanish. So suppose that we take Arabic as one, since that they both have to be together. So Arabic is one, German is or we can do Spanish as one, since all of the Spanish have to be kept together. And then there's gonna be 3 German, which can be arranged in any way. So German, German, German. So in this one, assuming that Arabic is 1 unit and Spanish is 1 unit, and the 3 Germans can be arranged in any way possible, then we can do so then there's 5 different ways to arrange these in total. So just these, we can do 5 factorial. And so we can solve this later, but we'll just leave this as this for now. And so in the Arabic, inside the Arabic ones, there's going to be equal to, since there's 2 Arabic ones, we can arrange the Arabics as x and y or y and x. So in the Arabic books, there's going to be equal to 2 factorial, since you can arrange the Arabic books in any ways in just that 1 unit. The Spanish books, on the other hand, have 4 factorial, since you can arrange the books in any way possible in the Spanish books. So then our total answer would be equal to 5 factorial times 4 factorial times 3 factorial, or times 2 factorial. And 5 factorial times 4 factorial times 2 factorial. Well, if we would solve this, then we would get 5 factorial times 4 factorial times 3 factorial times 2 factorial would be giving us 5,760. Once again, factorial is just that number times all the way until 1. So 5 factorial is going to be equal to 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. So then that means that if we multiply all of these together, then we'll be getting 5,760. So that means that there's 5,760 ways that he can arrange these books together. And that's how we got our answer choice C. Problem number 17. Ella begins to walk from her house toward her friend Bella's house. At the same time, Ella begins to ride her bicycle towards Bella's house. They each maintain a constant speed. Ella rides 5 times as fast as Bella walks. The distance between both of their houses is 2 miles, which is equal to 10,560 feet. And Bella covers 2.5 feet with each step. How many steps will Bella take by the time she meets Ella? So Ella's walking 5 times as fast as Bella, and the distance is equal to 10,560, which is equal to 2 feet. So we know that Bella can walk 2.5 feet per each step. So then for every 10 feet that Bella walks, a 10B, Ella can travel 50 feet. So 10B is equal to 58. Or it's not equal to, it's just like times. So then in total, that means I traveled 60 feet in total. So 60 in total. 60 in total. So I'll be running 60 total here. So then we got 10,560. Since 10,560 is a total, divided by just 60. So since we got that 60 is just right here. So 10,560 divided by 60 is gonna be equal to, if we would solve that, then 10,560 would be equal to 176. And now since we're calculating for Bella, how many steps will Bella take by the time she meets Ella, then we would have to do, I'll write that right there. So 176 times 10 would be equal to 1,760. So 1,760, that means that she would have that means that she would have walked in that much. And so then since you're asking how many steps will Bella have taken by the time she meets Ella, we'll have to do 1,000, so 1,760 divided by 2.5. So divided by 2.5. And if we solve that, then we'll be getting 704. So that means that she would have taken 704 steps when she meets Ella, by the time she meets Ella. And that's how we got our answer choice A, 704. Problem number 18. How many positive factors does 23,232 have? So 23,232, well, instead of finding all the factors of that, we know that 264 squared equals, well, if you just multiply it by 3, 264 squared is going to be equal to 69,696. And this is just times 3. So if we do times 3 to make it into this number here, then that means that 1/3, that means that 23,232 is 1/3 of 264 squared. And then that would mean that the factors of 69,696 would be equal to 11 squared times 82 times 3. And this is just a prime factorization of this number. And so that would mean that 23,232, well, the prime factorization would be equal to 2 to the power of 6 times 3 to the power of 1 times 11 to the power of 2. And we just do this because the cube root of 8 is equal to 2. And so we can also just do the prime factorization of this number right here, and we would get this as well. So then we would have to do how many positive factors are there? Well, since we can add 1 to each of the powers, since they're actually just positive factors, and so to do that, then we would be getting 7. Well, 6 plus 1 is equal to 7. 7 times 3 plus 1 is equal to 2. And then 2 plus 1 is equal to 3. We can just multiply all of these numbers together. And when we do that, we're going to be getting 14 times 3, which is equal to 42. And that's how we got our answer choice E, 42. Problem number 19. A sign pyramid, a cell gets a plus sign if 2 cells below it have the same sign. And a cell gets a negative sign if 2 cells below it have different signs. The diagram below illustrates a sign pyramid with 4 levels. How many possible ways are there to fill the 4 cells in the bottom row to produce a plus sign at the top of the pyramid? So this problem is just teaching us that negative times negatives is equal to positive, and positive times positive is equal to positive. Negative times positive is equal to negative, and positive times negative is equal to negative. So if there's positive positive, it's gonna equal positive. If it's negative negative, it's gonna equal positive as well. So for these 3 ways, and we know that we know that the bottom 4 has to be equal to 2 positive and 2 negative in order for this to work. So for these 3, for the left 3 or for the right 3, so let's just assume for the left 3. The left three, we can arrange these in as many, well, there, we can arrange these and we can arrange these freely. So there's gonna be equal to, we can choose two of them freely. So there's gonna be 2 to the power of 3, which is gonna be 8. 8 different ways to arrange these three. So to arrange these three, and we can choose these freely. So there's gonna be two ways, and there's gonna be, so two ways. By two ways, I mean negative and positive. And there's going to be, we're going to do cube because there's going to be 3 different ways to do this, and that will be giving us 8. Suppose that this side is going to be equal to negative, and this one is going to be equal to negative as well. And, or maybe we can do maybe positive, 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 positive. So positive and positive, and this is going to be equal to negative and negative. Well, then this side will be equal to positive, this side will be negative, positive here. So then this would be equal to negative, and this would be equal to negative, and negative, negative equals positive. And any way you take, there's going to be 8 different ways, and there's going to be 8 different ways to do this. So you can take any ways possible. There's going to be 8 total ways to do this, and that's how we got our answer choice C, 8. Problem number 20. In triangle ABC, point E is on side AB with EA is equal to 1 and EB is equal to 2. Point D is on AC so that DE is parallel to BC. So DE is parallel to BC. And point F is on BC so that EF is parallel to AC. What is the ratio of the area of CDEF to the area of CABC? And so to find the total, and so instead of finding the total area of this and then doing a ratio with the total area of ABC, we can just take the answer choices to our advantage, and we can proceed. So we know that, so if this side is going to be equal to 1, then this side is going to be equal to 1, this side is going to be equal to 2, this side is going to be equal to 2. Since that EFE is going to be parallel to AC. So this side will be equal to this side, or it's going to be sometime in that ratio. So then this means that this is going to be equal to, suppose that this is going to be equal to height, 1 height, this is going to be equal to 2 height, and this is going to be equal to 1 plus 2 height, so it's going to be equal to 3 height. Well, this won't really matter, but then this will be giving us that it's going to be this side over here, so both of these combined. So if we combine these two triangles, so this triangle plus this triangle, the area of that will be greater than this side alone. Well, if this side will be the total area of this, then this side will be maybe equal or maybe greater than this side as well. But we know that this side is going to be lesser than both of these areas combined. Because if we divide this triangle in half, this triangle and this triangle, both combined will be less than these two triangles. So that, and then this will prove us that this so CDEF is going to be less than 1/2 of the total area. And so since we can take the answer choices to our advantage, we can cancel all of the ones that are greater than 1/2. So 2/3 is greater, 3/5 is greater, 5/9 is greater, and 1/2 is equal, but we know that's going to be less than 1/2. 1/2 is equal to 1/2 and not less than 1/2. And so since the process of elimination, our answer choice is A, 4/9. Problem number 21. How many positive 3-digit integers have a remainder of 2 when divided by 6, and a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11? So first, we can start off by finding the least common multiple of these numbers. So the least common multiple of 6, 9, and 11 would be equal to, well, what's the least common multiple of that? So if we want to find the least common multiple, then we would have to do the least common multiple of 6 and 9 is gonna be equal to, well, it's going to be equal to 18. Yeah, it's going to be equal to 18. And then the least common multiple of 18 and 11 is going to be equal to 198. Since 11 is a prime number, we're just going to have to multiply those two numbers together. And 18 times 11 is going to be equal to 198. So then that gives us the least common multiple of 6, 9, and 11 is going to be equal to 198. Now, something that's going to be really important is that 6 minus 2 is going to be equal to 4. 6 minus 2 is going to be equal to 4 here. I'll just be underlining it. 6 minus 2 is going to be equal to 4. 9 minus 5. What's 9 minus 5? Well, 9 minus 5 is going to be equal to 4. And then we also have 11 minus 7. So 11 minus 7 is going to be equal to 4 as well. So all three numbers, well, the remainder, like when we subtract it, it's going to be equal to 4. So then, since we're asking for a multiple of thus the three-digit integers, well, then 198, well, something like maybe 198a, or we can do 198x. 198 minus 4. This is going to be our equation for the three-digit integers. How many are there? 198x minus 4. Well, if we do this, suppose the x can be equal to 1, x equals 1. Well, then if x is equal to 1, then we can do 198 times 1, which is going to be equal to 198, minus 4. So 198 minus 4 is going to be equal to 194. If x is equal to 2, then we'll get, what's 198 times 2? Well, 198 times 2, if we multiply it, then we're going to get 300. If we multiply, then we'll be getting 396. So 396 minus 4 is going to be giving us 392. And if we do x equals 3, then we're going to be getting 590. X equals 4, we'll be getting 788. Or, yeah, 88. And then if we do x equals 5, then we'll be getting 986. We will have space to do x equals 6, because if x equals 6, then the number will be greater than a three-digit number. And 1,000 is a four-digit number, so it cannot be greater than 999. And x equals 5 is already close enough to 100 and is already close enough to 999. So then that will not work. So then since there's 5 integers, three-digit integers, which is the least common multiple of 6, 9, 11, or is the multiple of 198 minus 4, 198x minus 4, then since there's 5 integers, our answer choice will be E, 5. Problem number 22. E is the midpoint of side CD in square ABCD, and BE is diagonal AC at F. The area of the quadrilateral at AFED is equal to 45. What is the area of ABCD? So they told us that the area of this quadrilateral ADEF here is going to be equal to 45. And now we need to find the area of EFC. Since we know that the area of ABC, so the area of ABCD is going to be equal to, we know that AC divides the square in half, so AC divides the square in half. So ABCD equals 2 times AFED plus 2 times EFC. So 2 times EFC. And we're not writing 2 times in the parentheses because inside the parentheses, because the one outside will be applicable to this one and this one. So we don't need to write 2 times inside the parentheses. So we know that ABCD, so the area of ABCD is equal to ABCD is equal to 2 times, so it'll be equal to 2 times 45, since they already told us the area of AFED is equal to 45. And now we need to find the area of EFC. And to find the area of this, they already told us that point E is the midpoint of side CD. So this whole side is equal to S, and since this is a side length, so it's a square, so that all side length will be equal, then this will be equal to S by 2. And so then if this is S by 2 here, then this would be, and then if this is S by 2 here, so this is also S by 2 here, S by 2. Well, we need to find the side length of this side. We need to find the height of this side to find out the area. So then if this is, so that we need to put this into ratio form. So then if this side is equal to S plus S by 2, which is equal to 3, so 3S, so this is going to be equal to S by 3, and this is going to be equal to, just S by 2. Well, this one won't really matter, so we'll just be doing S by 3 since this total area is going to be equal to S, so we can do S by 3. And so to find out what this is going to be equal to, we can do, to find out the area will be equal to area equals, this is just a formula, area equals 1/2 times base times height. And so the area will be equal to 1/2 times, what's the base? Well, the base is going to be equal to S by 2. And the height will be equal to S by 3. And if we multiply the numerator and the denominator, we'll be getting S squared, so S times S is going to be equal to S squared, times 2 times 2 times 3, which is going to be equal to S squared by 12. And so, we can write that here. So S squared by 12. S squared by 12 is the total area of EFC, triangle EFC. So then we can do that. We know that ABCD can be equal to S squared. Since it's going to be the side length times side length, that's just another formula to find the area of the square. We do side length times side length. So S squared will be equal to 90, which is 2 times 40, 2 times 45. So 90 plus, well, divide by 2, so it's going to be equal to S squared by 6. We could do times 6 times 6 times 6. We're going to get 6 S squared equals 90 times 6 plus S squared. And once again, we got this because if we do times 6 times 6, then we're going to get S squared times 6, which is going to be equal to 6S squared plus 90 times 6, and then the division and multiplication of 6 both cancel out with each other. And then we're going to just be getting S squared. Minus S squared on both sides, and we're going to be getting 5S squared is equal to 90 times 6. And then we can divide by 5 on both sides, and then we're going to get S squared equals, well, what's 90 divided by 5? 90 divided by 5 is equal to 18, and S squared is equal to 18 times 6. And S squared would be equal to, what's 18 times 6? 18 times 6 is equal to 108. So then S squared would be equal to 106. And remember, S squared is equal to the area of A, B, C, D. And so that's how we got our answer choice B. Problem number 23. From a regular octagon, a triangle is formed by connecting 3 random chosen vertices of an octagon. What is the probability that at least one of the chosen sides of the vertices is also the side of an octagon? So they're asking us that there's a triangle. Okay, so suppose that this can be a triangle where all 3 sides are touching the vertices. So 1 triangle, 2 triangle, 3 triangle, 3 triangle, and then it's going to be equal to 4 triangle, 5 triangle, 6 triangle, 7, wait, yeah, wait, 6 triangle, 7 triangle, and 8 triangle. So that means that there's going to be 8 ways where all 3 of the sides are going to be touching the side. Well, we'll be touching the side line. And since there's eight sides, and since that there's going to be 8 sides, and then we're going to have to do, so we'll suppose that there's 2 of the sides touching the octagon, and then we need the other side, like, well, we need, where should the other side go? So if, I'll be using the color pink. So suppose that this side and this side are connected. These both sides are adjacent. And there can be 6 more possibilities to go like that. That might be one triangle, another triangle might be like that. So there's 6 different ways like that. And so we can do 8 times 6 since there's 8 possibilities, 8 sides. There's going to be 6 more possibilities of the third side. And we're going to do 8 times 6 minus the 3 sides possibilities, like the 3 adjacent sides forming a triangle. So 8 times 6 minus 8. We have to subtract because they're asking us what is the probability that at least one of the sides of the triangle is also one side of the octagon. So then we're going to have to do 8 times 6 minus 8. And then on the bottom, it'll be, since there's 8 sides, we're going to have to choose 3 of the sides. Then we're going to do 8 choose 3, which is the same thing as 8 factorial over 3 factorial times 5 factorial. So 3 factorial times 8 minus 3 factorial. And so to represent this, we can do 8 times 7 times 6, 8 times 7 times 6 times 5 factorial over 3 times 2 times 1. So 3 factorial is equal to 6 times 5 factorial. And so if we do this, then we're going to cancel out the 5 factorial, cancel out the 5 factorial, cancel out the 6, cancel out the 6, and it's going to be equal to 56. So 8 choose 3 will be equal to 8 times 7, which is equal to 56. And so our bottom number will be equal to 56. And so the top number would be equal to 8 times 6, which will be equal to 48. 48 minus 8 will be equal to 40. And so 40 over 56 would be our answer. But then we're going to have to simplify it. So 40 over 56 would be equal to divide by 8 divided by 8. We're going to be getting 5 over 7. And so that's how we got our answer choice D, 5 over 7. Problem number 24. In the cube A, B, C, D, E, F, G, H, with opposite vertices C and E, J and I are the midpoints of edges F, B, and HD respectively. Let R be the ratio of the area of the cross-section EJ, CI to the area of the faces of the cube. What is R squared? So they're asking us to find what this area is, and then we're gonna have to turn this into a ratio form of this area to the total area of the cube. Or yeah, the total area of one of the faces of the cube. And so to find out the area of this, we're gonna do that the area of E, J, C, I would be equal to E, C square plus J, I square, and then the square root of that. And instead of doing a squared plus b squared plus c squared equals c squared, another way to do this is just the a squared, which is going to be ec, a squared plus b squared the square root of a squared plus b squared is going to be equal to c. And so to find out what EC is and JI is, we don't know what that is. So what is EC and what is JI? Well, to find this out, well, we can start off by finding EC. So EC would be equal to, EC would be equal to the square root of AC square plus AC square plus EA square. So AC square plus EA square. And so to solve this problem, then to solve this equation, we'll have to do AC squared. So what's AC squared? Well, to find that out, we can do the bottom right triangle. Since this is squared, then this angle must be equal to 90 degrees. So AC square, or we can do that AC is equal to the square root of AC, or the square root of AD, the square root of AD plus CD squared. And since we know that AD has to be equal to 1, or yeah, since AD is equal to 1 and since CD is equal to 1, since AD is equal to 1 and CD is equal to 1, then that would be equal to what's 1 squared? 1 squared is equal to 1, and 1 squared is also equal to 1, so 1 plus 1. And we'll have to know the square root of 1 plus 1, which is going to be the square root of 2. So the square root of 2. So AC would be equal to the square root of 2. Well then, what would be EA squared? So I'll just be writing this right here. So EC equals the square root of AC. So AC would be equal to the square root of 2 square plus EA squared. So what's EA? EA is also equal to 1 since it's a cube and all of the faces and all of the sides and all of the edges, all of the angles and everything is the same. So that means that EA is also equal to 1. So so now EC would be equal to, well, 2, the square root of 2 times 2 is going to be equal to 2, and 2 plus 1 squared would be equal to 3. So then EC would be equal to 3. Well, what's JI? To find JI, we know that JI here, JI is equal to BD. They both are parallel to each other. So JI is equal to BD. What's BD? BD is equal to BC plus, or the square root. So I'll be writing BC. So BD is equal to the square root, or the square of BC plus CD. Yeah, plus CD squared. And this is square root to everything there. So then that means that BD would be equal to 1 plus 1, so that'll be the square of 1 plus the square root plus the square of 1. So that means that BD would be equal to the square root of 1 plus 1, which would be 2. So BD is also equal to the square root of 2. So then we can do, so that J, oh wait, this is to find out what EJCI is, but then this is not the formula of the area. So then the formula of the area would be equal to EC times JI by 2. And so since we got EJCI would be equal to, well, what's EC? EC is equal to the square root of 3. So square root of 3 times what's JI? So since we know that JI is equal to BD, so JI equals BD ji is equal to bd. So that means that that means that is equal to the square root of 2. So ji equals bd equals the square root of 2. So then ji is equal to the square root of 2. And this is all by 2. So then EJCI is equal to the square root of 6 by 2. And now they're asking us, and now they're asking us, what is that? Well, now they're asking us, what is r squared? So to find out what r squared is, we're just gonna be simply doing, we can simply be doing that. So just do a square sign, just do the square root of 6 over 2 times the square root of 6 over 2. And since the square root and the square cancel out with each other, then we will be getting 6 over 4, which is gonna be giving us 3 over 2. 6 over 4 simplified will be giving us 3 over 2, since we have to do, we got a 4 because 2 times 2 is equal to 4. And so our final answer would be C, 3 over 2. Does anyone have any questions on this problem? Okay. So problem number 25. How many perfect cubes lie in between 22 to the power of 8 plus 1 and 2 to the power of 18 plus 1 inclusive? So inclusive means both of the numbers combined as well, or both of the numbers included as well. So 2 to the power of 8 plus 1. Well, 2 to the power of 8 plus 1. Well, 2 to the power of 8 is equal to 256. So 256 plus 1 is going to be equal to 257. Since 2 to the power of 18 is such a big number, we don't need to calculate everything. So then we can write this in a simpler way. So 2 to the power of 18, we can ignore the plus 1 for now. 2 to the power of 18 is going to be equal to 2 to the power of 6, in parentheses, times 2 to the power of 3. And so that will be giving us 2 to the power of 6, which is going to be equal to 64 to the power of 3. So that gives us that 64 is the largest possible cube that's possible to fit in between 2 to the power of 18 plus 1. And they're asking cubes, just saying, so 64 is the largest. So I'm going to write largest here, to just remember here. And now, since we found out the largest, we need to find out the smallest. So this number, so it has to be bigger than 250. The smallest cube, perfect cube, which is bigger than 257 is, well, 6 cube is equal to 6 times 6 times 6. 36 times 6 is equal to 216. But 216 is too small, and so we need a bigger number. Well, 7 cube is going to be equal to 7 times 7, which is going to be equal to 49. 49 times 3 is going to be equal to 343. And 343 is perfect. It's the smallest perfect cube that is greater than 257. So the smallest one is going to be 7, and the largest one is going to be 64. So then we can do 64 minus 7 plus 1. Remember the plus 1 here, and we have the plus 1 here. So then plus 1. And so 66, and we have to add plus 1 here, and we can't add it there because we don't know the exact value of this. We just know that this is the largest cube possible. So 64 minus 7 plus 1, and 64 minus 7 will be equal to 57. 57 plus 1 is going to be equal to 58. And so that's how many perfect cubes lie between 2 to the power of 8 plus 1 and 2 to the power of 18 plus 1. And that's how we got our answer choice E, 58. Does anyone have any questions or any on this or anything that we talked about so far?